Welcome to our podcast series Inside Semicon, and in today's episode we will be talking all things sub-fab, what they are, how it's developed over time, and what the impact is of downtime. So welcome to the third episode of Inside Semicon, the podcast organised by Kuehne+Nagel. I'm your host, Tom Mulders, and I'm here with John Desmond. John, good to have you here again.
Thanks, Tom. Good to be back. And I think today's episode is actually going to be quite interesting. It's something that a lot of people are not aware of, that basically the sub-fab and the fab are, two sides to the same coin. So hopefully we'll go into that. I think as well there's been a change for us both as well. We have now new roles within Kuehne+Nagel. So I'll go ahead and just update the people on what my new role is. So I've moved into a global role as VP of High-Tech and Semicon within Kuehne+Nagel. The idea being there to drive strategy and to drive further engagement and be more customer-centric with the existing customers and obviously with new customers that we onboard, which is obviously why this podcast is also so important, because we need to educate a lot of people on exactly what this new semiconductor, which literally drives the cars and every piece of device that we have, and why it's becoming so important. So I think this podcast will allow people, and the layman, I mentioned that in the previous podcast, to understand, what we're doing and where we're going with Semicon. And I think the same for you, Tom. You've a new role as well.
Yeah,
you're taking on.
Yeah. Well, first of all, congratulations
Thank
to
you
you
very much.
Your new role. I've also got a new role. I'm a global key account manager now for our high-tech and Semicon customers. I'm very much looking forward to working in that new role.
Great. Yeah. And we'll be working a lot together as well now.
Exactly. We will.
Yeah, which is going to be fun, I'm sure.
I'm pretty sure we'll have fun. So today we're talking about sub-fab. Now, before we kick off, John, can you explain to me in layman terms, what is sub-fab? What does it stand for? What is it? How do you describe it?
Yeah, this is going to tie in a previous episode where we discussed the fab, which is the fabrication. In terminology, they've shortened it to fab. But it doesn't exist in a vacuum, and it does need a lot of resources to enable what happens, we call it upstairs in the fab. Going back again to this famous cooking cake analogy, it's like having the oven, but you need electricity and light, you need extraction, you need the materials, all to allow the oven to make what it has to make. So the sub-fab is the second side to the same coin. Mm-hmm. So therefore, without it, the fab wouldn't exist. It wouldn't get the materials, the heat, the power, the lighting that it needs. So all of these ancillary services that's required is what we call the sub-fab. And that usually sits downstairs under the fab so that, it's actually removed so that any vibration, noise, and dirt that's generated from these heavier pieces of equipment, which are moving around a lot of air and water and gases, doesn't affect the fab itself. So it is actually part of the manufacturing process, but referred to as a sub-fab because it's beneath the fab itself.
Okay. And John, explain to me, what would you consider to be sub-fab? So you've explained the term itself, right? What is sub-fab exactly?
Yeah, so I think the best thing here is I've brought in another old piece of kit, and I'll bring it up. So what I have here in my hand is one of these old Polaroid cameras. It's probably a good way to explain the fab and the sub-fab in one small package. So this is the old Polaroid camera where you take the picture, and then you would pull out from the front of it the photographic plate. And then, shake it like a Polaroid as the song goes. Probably out of date by now. But then, then you'd peel off the layer and then suddenly an image would appear. So what that does is the fab upstairs will actually be, in very, very basic layman terms, taking pictures. And it's putting those pictures onto a wafer die, onto an actual piece of wafer. But as you can see, it doesn't just stop there. There are other chemicals needed, and there's air needed, and there's light needed. And that's where all of those elements come together from the sub-fab. So while the picture is being, placed onto the wafer itself, what happens is then the chemicals, the air, the necessary ingredients that are required to move things further actually come up from the subfab, and they're actually then brought into the bigger pieces of equipment, which are provided by the usual suppliers like KLA and Lam Research and Applied Materials, just to name a few. And then they all come together, and basically you get your finished product, which in the Polaroid case is the picture, but in the case of fabrication, the wafer fabrication, is the finished die. But the subfab provides all the necessary ingredients to get up into the fab to allow that to process it to produce the final product. So it's an integral part. One can't exist without the other. It's a symbiotic relationship. The fab can't produce without the materials downstairs in the subfab, but the materials in the subfab are of no use if the fab upstairs is not using them. So it's quite an intricate dance, so to speak, because you can only use certain materials at certain times from the subfab. But everything down there, from the heat to heat extractors to water purifiers, gas delivery systems, vacuum systems, even humidity, temperature and light control would be considered to be part of the subfab.
Okay. And how has subfab evolved over the last years? So while the basic tenets in terms of chemistry and so on is still the same, it's becoming way more, how would I put this, efficient in terms of the power modulations and the power delivery systems, and also the recirculation of heat. So before, obviously, the heat exchanger would just take heat out of the air to keep it cool, but now they're using that heat then to drive other parts of equipment in the subfab. The same with the cooling, the same with the water, and it all kind of shows that the progression is on sustainability. So they are becoming more and more sustainable. There are more and more devices downstairs that are constantly monitoring temperatures, constantly keeping items cool. So there is kind of a sustainable element going on down there, and that's the biggest, I would say, advancement in the last 10, 15 years. But also going back to when I was, in the subfab, literally there would be a board on a piece of kit and you would look at it and see what the temperature was from the board. So you would do your checklist in the morning. You would walk around to all of your pieces of equipment and you'd look at it and say, okay, that's within specification, that's within specification. And then after 10 years, suddenly there was a LED display and then you could go through menus, you could get more and more information until eventually it's on phone. Yeah.
So then you can sit in your office and you've your phone and your iPad. You don't have to do your 10-kilometer walk of the subfab, and they are that big, to check all the pieces of kit. You could then see what's running good, what's running bad, what's running hot, what's running cold. And then you have in there, such as preventive maintenance, that allows you to see whether a piece of kit is 90% on the verge of failure or is it still running normal. And, from there you can see as well that you then have predictive maintenance and you then have, predictive analysis to allow you to see if a piece of kit is going to crash, if it's going to stop working, and then that will affect your equipment upstairs as well. Yeah. So the technology has driven more technology. It's like a perpetual motion machine.
Yeah, it's like a full circle moment, isn't it?
Yeah, correct, yeah.
Yeah, interesting. What about security though? Is that an important part for subfab?
In terms of access control, yeah, because, let's face it, you've got anything up to $150 million pieces of kit. One kit upstairs could be run by a piece of kit downstairs that's worth $60,000. So a vacuum pump or a heat treatment pump or whatever. But in terms of access control, yeah, these are pretty high security sites. And obviously everybody's badged and you have to check in and check out, because the damage you could do by not knowing what you're supposed to be doing, or you're in the wrong area, or God forbid there's a bad player in there that wants to come in and just cause problems. So security is paramount. Access control to certain areas is paramount. You have different levels, different layers of access that you can get access to. So you can't access all areas. You don't have an access all areas pass, but you are allowed to work within the area that you're A, qualified on, and B, that you have the proper credentials for. So security in that way is also, very, very important. But that also kind of ties back into the whole downtime. What happens if a piece of kit goes down in the subfab? So you could have, let's take, God forbid, a vacuum pump decides to stop working, because you could have 10, 20,000 of these pumps and one of them could just decide I'm not going to work today. It's Monday morning. I've been working all weekend, so I'm going to take a break. But that could actually impact the fab, which is producing wafers, hundreds of thousands of them, costing millions. And then because of one piece of kit, we have a problem with upstairs, and then everything could get destroyed, but it'll also slow down production. So you can't afford that. So that's where this preventive maintenance and this intelligent tooling comes back into play again, where you're constantly monitoring all of the equipment itself. And by doing that, then you're able to do a bit of predictive maintenance to say, this piece of kit is not operating optimal. It's still operating within the bandwidth to produce wafers and to keep the machine in the fab running, but we better take it offline and swap it out and swap a new one in. Yeah. And then you have the whole logistics of taking out equipment and putting in new equipment or putting in a refurb equipment. But you can imagine that happening for a couple of thousand, say, vacuum pumps, but then you have that across the water purifiers, the ion exchangers, the heat treatment. There's a lot going on. There's a lot of movement. The logistics of this is quite important, and you always have to have a spare on hand, because you can't take a piece of kit in the fab down for an hour when it's producing, maybe say 100 chips in an hour, and each chip is worth, I'm just giving you a figure, 800 each. I mean, that's 80 grand an hour. No one wants to have that down, and actually goes up exponentially. Yeah. The more complex the chip that you're developing is. So the preventive maintenance, the whole interactivity, the dance between the downstairs and the upstairs, the fab and the sub-fab is very important. And like any good tango and any good dance, two partners need to be working as one. If they're not, it just doesn't work. Yeah. So that's a dance analogy as opposed to a cake analogy that we're always using, kind of trying to take people away from thinking that we're going to be talking about cake again. So we're talking about Semicon and actually not building cakes,
Yeah. No, it's very interesting. And I think a lot of people that think about semiconductor logistics, they're imagining wafers and capital equipment, the big machines, the very expensive machines. But actually, it's the sub-fab that's also included, right? Yeah. It's an integral part to semiconductor manufacturing. You can't produce anything without a full running sub-fab.
Yeah, correct.
Right. So in terms of sustainability, right? Yeah. I sent you an article recently about how one of the semiconductor manufacturers is working to be more sustainable in their sub-fab, right? Can we mention the name? I think we can.
Yeah, I can, yeah.
So it was Samsung Semiconductors in Korea, where they had a water purifying installation. And back in the day, they would purify the water and basically push it back out into nature. Right? Yeah. But nowadays, which I found really interesting, is they're actually measuring the temperature of the river, right, and making sure that the water they put back into the river is exactly the same temperature. And because it's been purified so many times for semiconductor manufacturing, it's actually pure water, purer than the water in the river. Yeah. Right. So actually, it's contributing to a more sustainable environment.
Yeah,
right?
yeah.
But that's just one example. So how do you think, or how do you see that sub-fab can contribute to a more sustainable environment? How is sub-fab becoming more sustainable?
Yeah, I think that article that we were discussing actually over the weekend on Samsung in particular, it just kind of reflects the sustainable approach that a lot of these mega corporations are actually implementing. And I think for the environment, that's also very important. But I think as it goes forward, as the technology gets more intelligent, as you mentioned, instead of just putting the purified water out, they're now even measuring the temperature. So they now have the artificial intelligence, if you want to put it that way, but they have something constantly monitoring what's coming out. They don't just release it, they're now actually chilling it before it comes out so that it is acceptable to the environment and even better than the environment. The same with the air. They're constantly cleaning the air as well. So then when they release that air, that's even cleaner than the air they're taking in. So it is a big industry, obviously, but there's also a whole element of it that needs to continue development. But since the semicon industry itself is developing, every 2 years, we're all, blue in the face from hearing about Moore's law. But because of that law and everything doubling, faster and faster, and getting, better and better, it takes more energy and it takes more power, which gives off more heat. So the sustainable element of it and the heat exchanging element of it and the cleaning element of it also has to keep up. So I think this new material science has been constantly researched to see how do we handle the pollutants, and not necessarily the actual, pollutants in terms of what we would think of, but releasing hotter water than what is normal. It could be only 2 or 3 degrees, but in an ecosystem for fish and birds and whatever, 3 degrees is quite a big difference. So that's what they're actually, measuring to make sure the water going out is exactly the same temperature as what the current environment is. So it's a whole ecosystem there. But the logistics side of it as well, then, that's where I think is also important, because when we're moving product from, let's say they're buying a heat exchanger and it has to come from Germany to Italy, how do we get that there? It doesn't just, we're not at the science fiction where we can just beam me up, Scotty, and move it from one location to the other. We got to put it on a plane or a train or even a barge, which obviously being on water is probably the most sustainable we have, because then we're not using, air fuel. We have sustainable air fuel, but also electric trucks. Then can we actually move these on trucks? And this is something that's coming up a lot more. Customers are asking for this, and we're listening, and we have our own fleet now of electric trucks, and on some particular supply chains, some of the lanes we do use, electric trucks, vehicles to get from A to B, and that's part of it as well. So how do we contribute when we're when we're setting up the initial sub-fab, which is like building a house? You build the foundations first, and then once the foundations are in, then you can build a wall and so on. So the sub-fab, in terms of the foundations, needs a lot of old school technology. You're still using rebar, metal, in the concrete, in the foundations. You're still using older materials, such as concrete and so on, to build this. So that's, needs to be moved as sustainable as possible. So that whole element as well is something that needs to be continually developed. And we're getting there. And I think over the next 3 to 4 years now, especially with the new fabs coming into Europe, we're going to see a lot of new sustainable measuring devices and methodologies being used, because building a new fab is not a small undertaking. It's hundreds of billions of dollars to get one fab up and running, and it's a number of years, 3 or 4 years, before you even start producing. So there's not that many new ones being built, and it hasn't been over the last number of years. With the new CHIPS Act for the EU and also with the US, we see that more and more sub-fabs and fabs, at the end of the day, are being built. But I think as well, it takes us back. We now see Samsung investing across my feed. Italy, I think ST Micro have announced. And we know in Korea, Japan, they're putting a lot of money in. So right now is like a boom time for these buildings. So they are going to carry us through the next 10 years.
Yeah. I think it also ties in well with what we in logistics already know to be just-in-time delivery, right? It also, if you connect the dots between the preventive maintenance of the already existing fabs, right? It's up to us as Kuehne+Nagel to make sure that we do everything possible to get it there on time in the most sustainable way, right?
Yeah.
So sometimes a barge or a truck will be, the preferred option, but in some cases you can't. You have to put it on an aircraft, right? And it's great to know that we can then use sustainable aviation fuel instead of normal aviation fuel, and thereby also reducing our carbon footprint, right? And that ties in with the SBTi targets that our customers have.
Yeah,
right?
correct, yeah. There are certain elements of that as well that when you look at it, you will always have, again, being Irish, so I can say this, Murphy's Law. Yeah. But it'll always have Murphy's Law will happen. I mean, you plan for the best, in a fab and a sub-fab, you have the spares necessary. But it could be that you have a spare and you use it and you break it, and that's the spare. And then the next one you get is the wrong material. It's not
wrong color.
It's the wrong color, whatever. It's, you need a Teflon screw, but not a stainless steel screw. And then you have to get that part in, ASAP. Yeah. And the only way to bring it in from the manufacturing facilities, so you could be, it could be from, Dublin in Ireland, and let's just say they need it in Israel. So, 2 Intel sites there, and the manufacturing is in Dresden. I mean, you're not going to barge that because it'll take 6 weeks probably to get there, and then you're not going to put it on a truck because you're driving 3, 4, 5 days, 24 hours a day to get there. So you're right. So then you need that part. Otherwise, you're losing, as I made a reference to earlier, minimum 80 grand an hour, 80,000 euros an hour. So you want it there tomorrow. And that's when the great things about working in this logistics industry, you're presented with these challenges. At the end of the day, you do need to air freight it in. Sometimes it's a hand carry. It's literally a guy getting onto a plane with a bolt, and getting on and getting off the plane to hand it to a taxi driver who then takes it to the engineer on site. And that can take anywhere from a couple of hours, from A to B, as opposed to a couple of days. So sometimes you are stuck using, these kind of logistics methods. You have to use, as you said, the aircraft, but we will use sustainable air fuel on that. Yeah. And this is few and far between, and they really are a challenge because then suddenly, stuff is costing hundreds of thousands every minute it's down. So you need it there as soon as possible, and it'll always be the one thing that happens that year that everybody will talk about for the next 3 or 4 years to ensure it doesn't happen again.
Yeah, that's true. And also, when you look at semicon manufacturing in general, you can't just push a button and have everything running again, right? There needs to be certain quality assurance because the threshold for mistakes is so small that you have to have those quality steps before you turn on the machine or turn it off.
That's true.
Right? So it's not just the downtime of the actual machine; it's also some additional time to make sure that everything's running as planned.
Yeah. I mean, a good example of that, Tom, would be, if your car stops running, well, you just turn the ignition and it starts up again. But within the, the fab and the sub-fab and the wafer fabrication, if something, stops running, you then have to make sure that everything is purged, back to a zero state, because you're really going to have to reset. Now, there are, certain steps you can take. If it's a multi-stage, say, tool and it's in stage B, you can, pretty much put a door between stage B and stage A, so then you don't have to do the stage B again, but you do have to clean out stage A and make sure stage C is also good enough to keep the production running. But then if the problem is in the sub-fab, well, in that whole line that goes from stage A all the way down to the sub-fab, well, that maybe have to be purged, that has to be rechecked. So you could be talking a 2-hour time from when you actually restart the equipment downstairs and then it gets up to upstairs. Then they have to do their tests to make sure there's no contaminants, and then they have to check the wafer. So there's a lot going on there. It's not just a matter of turning the car on the key and everything starts up again. It could be a couple of hours process time before you're actually back running again. So which is why, as I was mentioned earlier about the progression of the sub-fab in terms of how it's progressed, everything now really is monitored. Everything is looked at. You're looking at the rotations within the equipment. You're looking at, the power draw. How much power is it drawing? Because if the power starts being drawn and starts going higher and higher, then that piece of kit is struggling. It's trying to get up the hill and it's still operating within relevant limits. But you can see it's just starting. So then you have to try to arrange a schedule to take out that equipment so that you're not affecting the equipment upstairs. And as I said, it's a dance and it's constantly going on. So both partners have to work in parallel with each other.
Yeah. So just to recap now, we've talked about what is sub-fab. We've talked about how we think it's going to evolve over the next years. We talked about the sustainability aspects and the reliability aspects and how that's evolved over the years. Is there anything else that you want to add to this?
I think what's going to be very interesting is that we'll be keeping an eye on the fabs, especially within Europe, because obviously we're based here, but obviously globally there's a lot going on. But I think the next 2 years is going to see a big change in terms of logistics, going to be a big change in terms of, what we ship, how we ship. Sustainability will take a big aspect on that. Resilience, because now we're going to have anything up, I think it's like 20 to 25 new plants, and there's new ones being, announced all the time. So it will change the landscape of logistics, within Europe. I think we'll see a lot more like electric vehicles being used. I think we'll be looking a lot more to see how supply chains interact. Center of gravity studies and all these, tools will be used now, especially within Europe, and especially within Semicon, because there's just going to be an influx of companies here, all drawing on the same resources, not only from people, but from planes, trains, and automobiles, road networks. So it's going to be an very interesting time in the next 2 to 3 years when these plants start coming online. So we need to, I think, just be on our feet. But that's the great thing about Semicon. Yeah. It's constantly changing. It's constantly giving us challenges. And some of them we can't solve straight away, but we will get there eventually, which is why we keep developing, keep pushing. The whole infrastructure and the whole ecosystem with that is Semicon.
Yeah, and what I'm really interested about is the recent developments in AI, right? Which is also a major driver for the semicon industry. But that's something we're going to be talking about in the next.
I think next podcast. Yeah, that will be a complete separate, because that's a whole thing going on.
Yeah, exactly. So I just want to thank you again for sharing your thoughts today. Really enjoyed it. And I'll see you next time.
See you next time. Thank you very much for having me again, Tom. Thank you. Thanks for listening to today's podcast, Inside Semiconductors and the Semiconductor Supply Chain. If you found any of the topics we discussed interesting and you want to find out more, you can find me on LinkedIn at John Desmond or go to Kuehne+Nagel's website.